Hello everyone, I hope you all are fine, right? Welcome to my new channel, Guruji Maths Tutorials. I am Pariksha Gupta and this is my new YouTube channel where you can learn mathematics from class 8th onwards, okay? So one thing I want to quote here to all of you. The only way to learn mathematics is to do mathematics, okay? So with this quote I want to say that if you really want to learn mathematics and want to clear your doubts, then please like, share and subscribe my channel, so that whenever you want to learn mathematics, if you have any doubt, you can directly come to my channel, okay? So let's start now. So welcome back guys. Now we will start our first video from rational numbers, the chapter 1 of class 8th, okay? Now before we go to rational numbers, first we will discuss some terms like natural numbers, whole numbers, integers, rational numbers, irrational numbers and real numbers. Now what these terms are, okay? इंटीजर्स क्या होते हैं, नेचुरल नंबर्स क्या होते हैं, सबसे पहले हम ये डिस्कस करेंगे, ओके? सो आई एम जस्ट अज्यूमिंग दैट यू आर ऑल अवेयर अबाउट द नंबर लाइन, राइट? व्हाट नंबर लाइन इज एंड हाउ वी कैन रिप्रेजेंट नंबर्स ऑन नंबर लाइन, ओके? सो आई विल जस्ट गिव यू अ क्विक रिव्यू ऑफ नंबर लाइन. इफ यू नो, वी रिप्रेजेंट नंबर लाइन in a single horizontal line, right? This goes to infinity, minus infinity to infinity, okay, and the center is 0, okay? If I want to represent positive numbers on a number line, it will goes like 1 2 3 4 and 5 and so on. Similarly, अगर मुझे नेगेटिव नंबर्स को रिप्रेजेंट करना है नंबर लाइन पे, तो मैं कैसे रिप्रेजेंट करूंगी? -1 -2 -3 -4 -5 and so on, okay? Now coming to our point, natural numbers. What natural numbers are, okay? The numbers which are starting from 1 2 and so on, okay? The numbers, I'm repeating it again, the numbers which are starting from 1 onwards, okay? So you can say that natural numbers are the set of positive numbers, right? For example, 1 2 3 4 5 6 and onwards, okay? So these all are natural numbers, okay? Now coming to second point, what whole numbers are, okay? So whole numbers are the natural numbers including 0, okay? So we can say that whole numbers are starting from 0, okay, including positive numbers, okay? So we can say that we can write an equation as natural numbers, okay, plus 0, okay? So if it is containing the whole numbers containing natural number including 0, okay? So I hope I am clear what whole numbers are, okay? Now let's move to integers, okay? I told you what positive and negative numbers are, right? Positive numbers 1 2 3 and 4 and so on, and negative numbers are -1 -2 -3 and so on, okay? What integers are? Those numbers, the collection of positive and negative numbers and 0, okay? So we can say that integers are set of positive numbers, that is 1 2 3 4 and so on, -1 -2 -3 -4 and so on, and it also includes 0, right? So this is the set of integers. अगर मैं इसको सम अप करना चाहूँ कि integers क्या होते हैं और हम उसको कैसे रिप्रेजेंट करते हैं, so this is my set, okay? It will goes from -3 -2 -1 0 1 2 and 3 and so on. So this is my set of integers. Okay, now coming to integers constitute of two types of integers, that is known as positive integer and negative integer. Okay, so you can understand by the name as well what positive integers are, positive numbers, and what negative integers are, the numbers those are negative are known as negative integers. Okay, now coming to rational numbers, this is our chapter number 1, so focus on this. This is the important part. Okay, so what rational numbers are? Those numbers which can be written in the form of P upon Q, P divided by Q. Okay, I am repeating it again. Those numbers are known as rational numbers which can be written in the form of P upon Q. Okay, what do you mean by Q? There is one condition. Okay, there is one condition in the case of rational number. When we are saying we can write any number in the form of P upon Q, the condition is this Q must not equals to 0. Okay, that means we can say, okay, now abhi question aayega, we are saying that 4 is a natural number, right? 4 is a whole number, 4 is a integer, is, अब हम क्या कह सकते हैं, 4 रैशनल नंबर है? नहीं, क्यों? आपके दिमाग में ये क्वेश्चन आ सकता है कि 4 तो नेचुरल नंबर नहीं है, बिकॉज वी कैन नॉट राइट 4 इन द फॉर्म ऑफ P upon Q, but yes, we can write 4 as 4 upon 1, right? If you see here, this is 1 here, which is not equals to 0, right? The denominator is not equals to 0. So this 4 upon 1 is equals to 4 is rational number. Okay, similarly if I say minus 3, okay, so we can write minus 3 as minus 3 upon 1, right? So this is equals to minus 3, which is also a rational number. Okay, similarly if I say there is one fraction, let us say simple fraction. Okay, let us say 4 upon 7. Okay, is this fraction is a rational number? We can write this fraction in the form of P upon Q. This is in the form of P upon Q, right? So this is a rational number, and our condition is also satisfying, that is Q, the denominator is not equals to 0. Okay, if I am writing here, see, if I am writing here 4 upon 0, first of all this is the value not defined, this is not defined value. Okay, we cannot divide any number by 0. Okay, this is not defined. Okay, and as well as our condition is also not satisfying, so this is not a rational number. Okay, now coming to next point, that is known as irrational number. Okay, this is, you can say that the opposite of rational number. Opposite of rational number means the numbers which cannot be written in the form of P upon Q, right? We have seen the examples of rational number. अभी हमने examples देखे rational number के कि rational numbers किस form में होते हैं, P upon Q की form में. But there are also some numbers which cannot be written in the form of P upon Q. Okay, for example, if we say root 3, okay, we cannot write this root 3 in the form of P upon Q. Okay, similarly root 5, root 7. Okay, so these all are irrational numbers, these are not rational numbers. Okay, now I hope irrational and rational numbers are clear to all of you. Now coming to our real number system. Okay, what real numbers are? If I tell you the definition of real numbers, you can say that it consists of rational number as well as irrational number. Okay, so number system बनाते हैं. Okay, so we can say that real number is equals to rational number. Okay, rational number plus irrational number. Okay, right? So we can say that real numbers is equals to rational number plus irrational number. Okay, now coming to our the topic that is known as rational numbers. Okay, So now let's discuss our topic that is known as rational number. I'll give you a quick review that what are rational numbers. The numbers which can be represented in the form of P upon Q, where Q is not equals to 0. Okay. Now there are some properties of rational number as well. Okay, like closure, commutative, associative, inverse, and identity. Okay. Now we'll see like the numbers which are natural numbers, whole numbers, integers, rational, whether these numbers are satisfying these properties or not. Okay, properties such as closure, associative, commutative, identity, and inverse. Okay, let's discuss the first property in the case of whole numbers, natural numbers, and rational numbers. Okay, so if I say what closure property says, okay, it says that if, let us say, we will consider the case of natural numbers first. Okay, I am checking the property, the closure property in the case of natural numbers. Okay, so what closure property says, if I am adding a natural number like A with another natural number, that is B, it will give me a natural number which is C. Okay, so let us check whether this is true for in the case of natural number or not. Let us say one natural number. Let us say one example here. Let us say this is 4. 4 is a natural number. We add this 4 with 5. 5 is also a natural number, right? Which will give you 9, which is also a natural number, right? So this property, this closure property holds for natural number in the case of addition. Okay, here we are taking the operation addition. Now let us take the operation subtraction. Okay, what does it mean? If I am taking the operation as subtraction, what does it mean? If I am subtracting a natural number from another natural number, it will give me a natural number. But if you are taking two natural numbers 4 and 5, and if you will subtract 5 from 4, it will give you -1, right? But -1 is not a natural number, right? So we can say that addition is in case of addition, closure property is holding, right? Let us check for multiplication as well, right? Let us say I am having two natural numbers, 4, or let us take another natural numbers. Let us say I am having 3. I will multiply 3 with 2, it will give you 6, right? So this 6 is a natural number, right? So I can say that the set of natural number is holding closure property in the case of addition as well as in the case of multiplication, right? But in case of subtraction, it is not holding, right? Now let us check for division as well. Let us divide two natural numbers. I am just taking the example 2 divided by 4, which will give you 1 upon 2, right? Which does not belongs to the set of natural number. This symbol is implies for belongs to. Okay, this means it is belongs to. Okay, and if I am writing like this, it means does not belongs to. Okay. Okay, so if I check in the case of division, 2 divided by 4, it means 1 upon 2, which does not belong to the set of natural numbers, right? So if I conclude all these 3 to 4 examples, we can see that if in the set of natural number, the closure property is holding for addition and multiplication. Understood? So we can this is our conclusion, right? We have checked for addition, subtraction, division, and multiplication. Okay, we performed 4 operations. Okay, let us check. This was the case in the this was the case of natural numbers. Okay, if I say if I want to check the closure property for whole numbers, then What whole numbers are? The numbers starting from 0, right? 0, 1, 2, 3, 4 up to so on. So those are known as whole numbers, right? Now if I want to check this closure property in the case of whole number, what does it mean? It means that if I am adding, okay, if I am performing any operation like subtraction, addition, division and multiplication, if I am performing any operation to whole numbers, it will give me a whole number, right? Let us check for addition first. Let us take two whole numbers, 1 plus 0, it will give you 1, right? It is satisfying, right? Let us check for addition, for subtraction. 4 minus 5, it will give you minus 1, right? Which is not satisfying, right? Let us check for multiplication. 5 into 4, which will give you 20, which belongs to which belongs to the set of whole numbers, right? Let us check for division as well. Let us take the example of 3 divided by 9. Okay, it will give you 1 upon 3, which is again not belongs to the set of whole numbers, right? So what we can conclude from these examples, that this closure property is holding in the case of addition and multiplication only. Okay, it does not satisfy for multiplication, for subtraction and division if we are taking the set of whole numbers, right? Let us assume the set be, let the set as rational numbers. Okay, the set of rational numbers. Okay, let us take two rational numbers. Let us take 1 upon 2 and 1 upon 4. Rational numbers are those numbers which can be written in the form of p upon q, where q is not equals to 0. Okay, so these are two rational numbers, 1 upon 2 plus 1 upon 4, which, okay, so which is equals to 3 upon 4, okay, which belongs to the set of rational numbers, right? So we can see here the addition, with the operation addition, the set rational number is satisfying the closure property. Let's check for division as well, for subtraction and for this you can say that multiplication and division. If I take let us say 4 upon 1 minus 5 upon 1, it will equals to minus 1 upon 1, right? So it is also belonging to the set of rational numbers. Let's take the example of operation as multiplication. Okay, let us say I am having 4 upon 5 multiplying with 3 upon 2. Okay, this will give you 12, 4 3s are 12, 5 2s are 10, which is also belongs to the set of rational number. Okay, now let us check the operation of division. Okay, division means if I am dividing two rational numbers. Okay, okay, so if I am dividing two rational numbers, that is 4 upon 5 divided with 3 upon 2. Okay, what does it mean? We can write it as in this form: 4 upon 5 multiply with 2 upon 3, which will equals to 8 upon 15, which also belongs to the set of rational numbers, right? Okay, so if you see here, this 8 upon 15 is also belonging to the set of rational numbers, right? Now what about a divided by 0? Okay, a means any rational number. If I divide any rational number, let us say 4 is a rational number divided by 0. Is it satisfying our closure property? No, no, right? So in the case of division, this rational number, the set of rational number does not satisfy the closure property. Okay, so we can conclude here that the set of rational number is closed under addition, subtraction and multiplication. It does not satisfy the closure property in the case of division. Okay, now let us take the set of integers. Okay, integers means negative numbers, minus 1, minus 2, minus 3 up to so on 0, and positive numbers, that is 1, 2 and 3. Okay, so let us say we have to check closure property for addition, subtraction, multiplication and division, right? So let us say two integers like minus 1 plus, okay, 4. Is it a integer? When you add these two terms, will it give you integer? Will it give you an integer? 4 minus 1 is 3, which belongs to the set of integer. Okay, so addition is closer, okay, in the case of integer. Now coming to subtraction as well, let us say 4, okay, minus 1, minus is plus, 4 plus 1, which will give you 5, which also belongs to the set of integers, right? Coming to multiplication, 5 into minus 3, it will give you minus 15, right? So will it give you, it is also belongs to the set of integers, right? Now coming to division as well, let us take two integers, minus 5 divided by minus 4, okay, this is equals to 5 upon 4. This does not belongs to the set of integers, okay. So same as in the case of rational numbers, we can say that the set of integer is closed under addition, subtraction and multiplication only. It does not satisfy the division does not satisfy, okay, it does not satisfy, it does not satisfy the closure property in the case of division if we are talking about integers, okay. So now if I want to sum up, अगर मैं इसको sum up करना चाहूँ, what in the case of what we have learned, natural numbers, okay, integers, whole numbers and rational numbers, okay. Now what are the operations? Plus, minus, multiplication and division, okay. So natural number is closed under addition and multiplication, okay. In case of subtraction and division, it does not satisfy closure property, right? Now in case of integers, what we have seen, it satisfies the closure property in the case of addition, subtraction, multiplication, but not division, right? Sorry, but not in the case of division. Now in the case of whole numbers, we have seen that it satisfies in the case of addition and multiplication, not in subtraction and division. In the case of rational numbers, we have seen that the closure property is satisfying in the case of addition and multiplication and subtraction, but not in division, right? So we can summarize this video in this form, that if we are talking about the properties of rational number, the first property, that is known as closure property, is not satisfying in these cases, okay. So we'll see rest of the properties in our next video. So please like, subscribe and share my video, okay. Thank you.